Welcome to The Explainer. Today, we're diving into a class of molecules that were once banned, driven completely underground, and are now making a huge comeback as a potential revolution in mental health care. We're talking about the science of psychedelics. Wow, okay, so this chart right here, it tells a really powerful story. In just the last decade, scientific research into these therapies has more than doubled. This isn't just some passing trend, it's a full-blown renaissance. But the big question is, why is this all happening now? To get that, we need to rewind a bit and see where this all started and why it all stopped. Yeah, this boom in research we're seeing, it's really act two of a much longer story. So let's do that. Let's go back in time. We're going to go from ancient rituals to a point where the science just got completely shut down in the 20th century. You know, for literally thousands of years, indigenous cultures saw these things as sacred teacher plants. Then the 1960s happened, and boom, they exploded into Western culture. But then, just as quickly, the door slammed shut. By the 70s, strict bans brought almost all the science to a dead stop. Remember that big dip on the first chart? Yeah, that's what that was. Decades of silence. Until now, of course. Okay, so what exactly are we talking about here? What are these molecules causing all this excitement? Well, let's meet the main characters. And our tour starts in the rainforests of equatorial Africa. Right, so this plant here is Tabernanthe iboga. Its roots have been used in ceremonies for centuries. And hidden inside those roots is the first molecule we need to talk about. And there it is, that's ibogaine. It's the active ingredient. Now, the reason scientists are so fascinated by this one is its potential to tackle something really tough, drug addiction. I mean, it's a problem where, let's be honest, a lot of our current treatments just don't work for a lot of people. So ibogaine's power comes from how it works. It's not a simple one-and-done kind of thing. It hits multiple targets in the brain. It works on these things called neurotrophic factors. You can think of them as like fertilizer for your brain cells, helping them grow. And at the exact same time, it's working on the opioid receptors. Yep, the very same ones that are tied up in addiction. It's this one-two punch that makes it so promising for things like opiate detox. All right, next up, DMT. This one's pretty famous for being incredibly powerful. You find it in a bunch of plants, like this one right here, Psychotria viridis. It's actually a main ingredient in that traditional Amazonian brew, ayahuasca. Okay, so how does this stuff actually work in your brain? This diagram looks super complex, I know. It's like a big chemical dance. But don't get bogged down in the details. I just want you to zoom in on one thing. See that little label there? 5-HT2A? That's a serotonin receptor. Just file that name away. Trust me, it's going to be super important later. It's kind of the key to this whole puzzle. I'm pretty sure you've heard of this next one. It's the psilocybin mushroom. You probably know it as the magic mushroom. So here's the cool thing. When you eat one of these, the main ingredient, psilocybin, doesn't actually do much on its own. It's what's called a prodrug. It's like your body becomes a little chemistry lab and turns it into this molecule, psilocin. And that is the stuff that actually gives you the effects. And get this, psilocybin does more than just create a trip. It seems to kickstart neuroplasticity, which is just a fancy word for the brain's amazing ability to rewire itself. You can think of something like depression as the brain getting stuck in these deep negative grooves, right? Well, psilocybin seems to help the brain build new roads, new pathways out of those ruts. It's a huge reason why people are so excited about it for depression. And of course, we can't forget the most famous one of all, LSD. Now, this one's a little different. It's semi-synthetic. It was first made from a fungus that grows on rye bread. But you guessed it, it has that same kind of complex, really interesting relationship with the brain. Okay, let's pause for a second. We've got a molecule from a root, one from a leaf, one from a mushroom, and one from a lab. They're all so different. So how in the world do they all create such similar, profound experiences? Well, it turns out they all have a key to the very same lock in the brain. And here it is. This is the big aha moment. Look at these two diagrams. On the left, DMT. On the right, LSD. They look complicated, but zoom in. Remember that receptor I told you to remember? The 5-HT2A one? There it is, in both. That's the common denominator. It's like the master lock that all these different chemical keys can fit into and turn. And once they turn it, that's what seems to kick off the whole psychedelic experience. All right, so let's shift gears. We've seen the chemistry, now let's go from the lab to the clinic. How is all this science actually being used to create new treatments for really tough mental health conditions? And the potential here, it's just massive. We're not talking about minor issues. We're talking about huge challenges, like major depression, PTSD, all kinds of addiction. I mean, these are conditions where, for way too many people, our current treatments just don't cut it. So now, the big hope is that psychedelics might offer a whole new way forward. But hold on, this isn't some magic cure-all. We have to be really honest about the risks. Look at this number, 77%. In a big clinical trial for psilocybin back in 2022, a whopping 77% of the people in the study had some kind of adverse event. Now, a number that big, we got to talk about what that really means. Okay, now, to be fair, most of those adverse events were things like headaches or feeling nauseous for a bit. But that 77% number drives home the single most important point here. These are not drugs you just pick up at the pharmacy and take at home. No way. Their sheer power means you absolutely need a safe, controlled environment with medical professionals watching over you. And that's the whole idea behind something called psychedelic-assisted psychotherapy. So you've got all this incredible promise on one hand, and all these very real challenges on the other. So what's next? What does the future of psychedelics in medicine actually look like? Well, the road from the lab to your local pharmacy is definitely not a straight one. It's going to take a huge team effort. The researchers are really clear on this. You need psychiatrists, chemists, even ecologists and policymakers, all working together to figure out some pretty big hurdles. I mean, think about it. The practical questions are enormous. How do you get the same dose every time from a plant? And if these plants become super valuable, how do we stop them from being wiped out? Plus, who's going to pay for the huge, expensive clinical trials you need to get these approved? And you have to do all of that while dealing with decades of legal and cultural drama. It's a lot. So we've gone on quite a journey, right? From ancient plants all the way down to tiny receptors in the brain and back out into the modern clinic. And it leaves us with this one really powerful question to think about. Could it be that these ancient compounds, the ones that were pushed aside for so long, are about to completely change the game for modern mental health care?